So for this review, let's take a look at how to solve a system of three equations and three unknowns. So we have 2x plus y minus 3z equals 5, x plus 2y plus z equals 7, 4x minus 3y equals 0. There's multiple ways of solving a system of equations. The way that I will do it here is by using an augmented matrix. So 2, 1, negative 3, 1, 2, 1, 4, negative 3, 0, and augment that with the solutions 5, 7, 0. All right, to get started with this, I will interchange the first two rows. I'd like to have a 1 up here if I possibly can. I could divide the top row by 2, but it's a whole lot easier just to interchange the top two rows. So 2, 1, negative 3, 5, and then 4, negative 3, 0, 0. Next, I'll do Gaussian elimination. So the top row stays the same. And then I will rig things so that I get zeros on both of the first entries in the next two rows. So I need to multiply the top row by negative 2 and add. Multiply 2 by negative 2, I get negative 4. Add to 1, I get negative 3. Multiply this by negative 2, I get negative 2. Add to negative 3, I get negative 5. 7 times negative 2 is negative 14, plus 5 makes negative 9. Same idea for the bottom. Multiply by negative 4 and add. Multiply by negative 4, I get negative 8, plus negative 3 makes negative 11. Multiply by negative 4 plus 0, I get negative 4. Multiply by negative 4, I get negative 28, plus 0, I get negative 28. Okay, next, again, I want to have a 1 here. Here, there's no easy way to do that other than just multiplying by negative 1/3. So top row stays the same. For the next row, multiply by negative 1/3, so 0, 1, 5/3, 3. And I'll copy down the third row here. Next, top two rows stay the same. For the next row, I'm going to multiply by 11 and add. So 0 times 11 plus 0 makes 0. 0 times 1 makes, 11 times 1 makes 11, plus negative 11 makes 0. 11 times 5/3 minus 4 plus negative 4 ends up with 43/3. And then 11 times 33 makes 33, plus negative 28 makes 5. So now I have an upper diagonal system here, and so I can convert this back to equations. So the top row becomes x plus 2y plus z equals 7. The row after that is y plus 5/3 z is equal to 3. And then the last row is 43/3 times z is equal to 5. And so I can do back substitution to solve for these. So z is going to be equal to 15 over 43. Coming back over here, we get y plus 5/3 times 15 over 43 is equal to 3. And so just simply solving for y, we end up with y is equal to 104 over 43. And then coming back over here, we get x plus 2 times 143 over 43 plus 15 over 43 equals 7. And if we solve for x, we'll end up with x is equal to 78 over 43. And so that's our answer, that the triple xyz is equal to 78 over 43, 104 over 43, and 15 over 43. And that is the unique solution to that system of equations.